Before we begin, we would like to acknowledge the traditional custodians of the land in which we are based, the Gadigal people of the Eora Nation, and pay their respect to their elders past and present. Hi everyone, welcome to the first episode of EWB UNSW's Inspire podcast series, a platform where we converse with interesting people and share their learnings. My name is Rong Shuan, and I'm a third year aerospace and material science student at UNSW, and I'm currently the partnerships director at the local chapter for 2022. Alongside me is my co-host Winnie. Would you like to introduce yourself?
Sure thing. Thanks, Rong. My name is Winnie, and I'm a second year software engineering student, and I work alongside Rong in the partnerships team for this year.
So today we're joined by our esteemed guest, Dr. Fiona Johnson, who's currently an associate professor and researcher at UNSW in the School of Civil and Environmental Engineering. Would you like to introduce yourself?
Hi, Rong. Hi, Winnie. Yes, my name's Fiona Johnson. I'm an associate professor in civil and environmental engineering at UNSW and super excited to be here today to chat to you all.
Cool. Thank you. We're excited to have you here as well. So I guess to kick things off, we might start with a few icebreaker questions, some fun, like, would you rather questions.
Okay.
Get the ball rolling. So, Dr. Johnson, would you rather chocolate or vanilla?
Ooh, that's a hard one. I think chocolate, dark chocolate.
Oh, okay. I like that. What about dogs or cats?
Dogs.
Dogs? I think I'm the same. And would you rather fight 10 duck-sized elephants or one elephant-sized duck?
Oh, definitely the duck-sized elephants. I really am quite scared of birds.
Oh, okay. That's a good
They're
answer.
evil.
Cool. Thank you. Thanks for sharing all those fun answers. And now, I guess we'd love to get right into your journey through engineering. And I guess to start us off, many of our audiences have just started uni or are in their final years of high school, and they're considering engineering as a potential career path. And so we'd kind of love to know, when did you know you wanted to get into engineering, and how did you decide the field that you wanted to study in?
Yeah, so in high school, I was very interested in maths and physics, but I also did art as well. And so for quite a while, I was deciding between architecture and engineering. I did those, when you're at high school, your careers counselor gives you aptitude tests. It said I was not suited to be an engineer. So I would take from that, if you want to be something, don't worry about what the aptitude test says, because I am an engineer and I have succeeded despite the aptitude test saying that maybe I wasn't going to be so good at engineering. But I did really love physics and maths, and my year 9 or 10 maths teacher, Mrs. Doyle, she was amazing. And she said, oh, you should apply for this Women in Engineering scholarship with ABB. And so I did that. And so I got a little bit of money in year 11 and year 12, just, I don't know, $1,000 or something. It was quite a lot when I was, 16. But what was more exciting about that was that I got to spend 2 weeks in the July school holidays of year 11 doing work experience with ABB. Now, ABB is a very big, primarily electrical engineering, power kind of engineering company. We went into their head office, which was at Circular Quay, and I was just like, whoa, I want that corner office. I'm now at UNSW, so I don't have the view of the Opera House, but I think my life's better anyway. And we also went out to lots of their different sites. And it was an amazing week. We had 2 weeks. We had lots of fun with the other year 11 students as well. But one of the days we went to Willarawang Power Station out in Lithgow. But what was really cool was we got to speak to the engineers that weren't just electrical engineers. We spoke to the civil engineers, and I was like, oh, this is what I want to do. I don't want to do power generation. I want to do civil. I want to do infrastructure. I want to build structures. This is so cool. So when it came to the year 12 where you were picking courses, I just put down 3 civil engineering UNSW, civil engineering Sydney Uni, and civil engineering UTS. No other preferences on my UAC forms at all. I was set. Civil engineering was where it was going to be. I had a friend outside of school who was a few years older than me who was doing civil engineering at UTS, but she was the only person I knew who was an engineer. But and I'd done chemical engineering work experience in year 10, but I was also fairly sure I didn't want to do chemical engineering. I was more into, infrastructure. So I picked UNSW mainly because I found the open day really friendly, and I was offered a co-op scholarship, which was pretty amazing to then get work experience during my degree as well. And so I started at UNSW many, many years ago. There were fewer buildings on campus. The Red Centre wasn't there. The Scientia building wasn't there, but the civil engineering building is exactly the same as it was. And yeah, I did it took me 5 years because I had an extra year of work experience in the middle. And as those of you studying civil engineering know, you don't get many electives until 4th year anyway. And through the first few years of engineering, I still wanted to be a structural engineer, but I ended up as a water engineer because I ended up working at a consulting company, as part of my work experience. At 2, actually. The first one I went to, I said, I want to be in your structural engineering group. And they said, no, structural engineering is boring. Go into our geotech group. And I was like, oh, this is amazing. We were working on a big highway upgrade. The guys I was working with were super smart. We were doing really cool modeling to see how we could make building this road quicker because it was all on soft clays. So that was amazing. I was there for 6 months at SMAC. And then after I left SMAC, I went to what was then, we changed names a lot, but let's say KBR, what is now KBR now. And they put me in the civil and environmental group, and I ended up doing lots and lots of water flood studies and things. And I was like, no, actually flooding and water, that's where it's at. And so when I finished my degree, I still did geotech courses because I didn't want to do a wastewater treatment course. But other than that, then I just stayed on at KBR as a graduate engineer. And here I am 20 years later. So
So interesting, yeah. Coming from I guess the infrastructure side of civil engineering and then moving all the way towards the I guess the water resources and all that kind of stuff. That's I didn't realize it was so diverse in that kind of field.
Civil engineering is an amazing degree because it is so broad. Anything to do with what we do within our wider environment. In the end, I love water engineering because it's almost an art. We don't really know how much water's falling or how that water's going to move across the catchment. And so we use lots of cool statistics and, analysis to try to make the best decisions we can. And so I think that, and I love, as a kid, we used to go to camping near rivers. And so the power of water has always been something that I guess I'm quite passionate about.
So interesting. And I feel like the field that you're looking at is really important too. And do you feel like engineering in general, like civil engineering and the things you're looking at, is becoming more and more important, more popular for people to kind of delve into in their career path?
I mean, I think having a job where you feel like you're making a difference is for me vital. That's why I get up each day. And so I think there's amazing opportunities in all of engineering, but in what I do particularly, to try to minimize the impact of human development, but also ensure that we've got equitable development around the world, and that that we make the best decisions we can in a changing environment and in a limited data environment. So technically I love the maths of it, and then I love thinking through the implications of making sure we've got enough water when we need it and not too much water when we don't want it.
Yeah, no, it's pretty fascinating, how you've got you're exposed to all those different experiences, and I do want to kind of take a step back a bit. Could you kind of explain in simple terms what hydrology is or what it means to be water engineers? Yeah.
So essentially, hydrology is a science, and then when we take that, I guess, into engineering, then we think about being water engineers. And so what we're really looking at is how much rainfall is falling on the land, on the catchment, and then where does that water go? and how do we manage that flow within cities, within rural areas, and within the environment to make sure there's enough for the environment, but also that the river levels aren't getting so high that we can, you know, cause flooding, or at least understanding where that flooding will occur, because we can't flood proof anywhere, but we can understand risks so that we use the land in appropriate ways, so that we don't build a preschool next to, you know, a floodplain where, you know, the kids are going to be flooded. So really it's about, the thing is though, that we don't really have great ways yet of understanding how much rain is falling across the whole catchment. We can measure some of it with radar, like you see on the app from the Bureau, or, you know, we can do some stuff with satellites, but generally we're using a rainfall gauge, which is just like a little bucket. And we've got some of those spread around, and then we need to make our best guess of what's happening across the rest of the catchment, both in time and space, to make designs. And so when you're working in industry, often you're designing the size of the pipes that might go under the road, the culverts, or you might be seeing how big a channel is, or using computer models to help simulate where the water would flow across the land and where is good places to build houses and where's not. In research, we're doing a lot of work to try to leverage new technologies to better infill those sorts of gaps that I mentioned before, where we just don't have enough data, or using cool statistical methods, because the thing is, what we're really interested in is really rare events. And so we only have a few samples in, you know, the period over the last 100 years where we might have rainfall gauges. So how do we use statistics to best estimate how likely those sorts of events are? We then look at other methods of getting extra data for a catchment. So we might look at nearby catchments. We might look at other data sources. Like we've got a PhD student at the moment who's been using tree rings to try to recreate 600 years of flow for rivers where we only have 50 years of flow. So lots of methods of just trying to pull in data from wherever we can to make better decisions.
Yeah, wow. Okay, that sounds pretty interesting. You mentioned a lot like dealing with stats and data. And I'm sure like some audiences might be wondering, is what kind of like pathways, you know, do you have to undertake to get into hydrology? Because I know you've undertaken a civil engineering, but would someone say doing math or science might end up find their way into?
Yeah, so some hydrologists get into hydrology through earth science degrees, you know, Bachelor of Science in Earth Science or Bachelor of Science in Climate Change. Even through geography degrees, a physical geography degree you can end up sort of in studying catchments and processes. And then increasingly, you know, human geography too. How do people interact with the floodplain, with water? And so there are lots of paths to, I guess, hydrology. It is, and that some parts of hydrology are less mathematical and more fieldwork based, so going out and collecting data in the field. Our group at UNSW is much more statistically based, but you know, there's a big range of work that helps us understand our catchments better.
Yeah, makes a lot of sense. Yeah, and I think that's really cool how it all can come together in that kind of way. But yeah, so that's a lot about all your undergraduate experience, which I think is really interesting and exciting. But let's segue into your industry experience. And so I know you mentioned that you were a co-op scholar, and I think that's like so impressive, which is really cool. And I was just wondering, how was that like? Did you also, I think currently they do 3 placements within their degree. Did you also do something similar? And how is that in terms of being still a student, still studying, and might not knowing all the content and jumping straight into industry?
Yes, so when I was a co-op scholar, the program was that we did 2 summer placements and then 2 6-month placements. So I did 4 placements during my degree. And yeah, the first time at the end of first year where I did an industrial training placement for 12 weeks was pretty intimidating. I didn't know anything. I mean, especially in first year engineering where you're just doing you do lots of general maths and general physics and you don't feel like you've done any engineering at all almost. you might do one design course. But and so I worked for what was then Statewide Roads, and they were looking at upgrading highways. And so I was doing cut fill balance calculations and spent a couple of weeks out on site. And I think I was really shy and nervous. And even in my second placement at the end of second year, my boss said to me, you need to be more assertive. You need to give us your opinions. You need to be more proactive. And so, yeah, the workplace was quite a different environment from university, because you couldn't wait for someone to give you the information you needed. You had to be asking questions and bothering people, because if you just sat at your desk and hoped that someone would come and tell you what to do, it didn't really happen. And so I learned a lot about making decisions really quickly under time pressure, because I think that's one of the things about consulting, is that often you don't have a long time for the project. And so, we'd have a client meeting tomorrow, and it was like, well, we need some designs, so let's come up with them. And so, you kind of learn to swim pretty quick, which was a very good experience. I think the 6-month placements, I was a bit more senior by then, and the groups I was in, there's very different personalities in different groups too, and I think they probably were just different sorts of work that was going on. And so I found them by then I had a bit more confidence and was really feeling like I was contributing some stuff that, if I hadn't have been there, that work wouldn't have got done. So when I was at the end of first year, even photocopying reports back in the day was actually quite an interesting experience. We'd have to get we'd have to get a tender into a client, and it was before electronic submissions. So it was like, can you drive this across the city to Liverpool, and you need to be there by 3 p.m. because otherwise all this work that we've been working on for months won't be assessed by the client. So you learn a lot about that also then helps you well once you're at university and back at uni, and submitting your assignment on time, or you're printing out copies of the assignment and binding them because it's almost due. So there was a lot of transferable skills both ways, I think.
Yeah, that's so interesting. And I can see like how it definitely would help in terms of really dipping your toes into the industry and really understanding how it all works, because it's definitely different to what they kind of do in uni and all those kind of ideas there.
And some of the people that I worked with then, I still know now. So 20 odd years later, engineering is, parts of the industry are really quite small. And so, the friends and the contacts that you make are then going to be vital for the rest of your career, basically. So your friends now at university, or your friends, for next year when you come into first year, you could be working with for the next 30 or 40 years. It's pretty amazing.
Yeah, that's so cool. So then, would you say that the industry placements helped you with, I guess, your first job out of uni, and or did you kind of seek out something yourself? I guess in terms of how like, I guess, non-co-op students kind of navigate their way into the industry. Was that a bit more of how you did that after uni?
No, I was very lucky. I was working at my desk. So once my placement of 6 months had finished and I was back at university, I stayed part-time through my final semester of university. We had semesters at UNSW back then. And they just popped a contract on my desk and I signed it, and I just kept working. I didn't even really have a break. I take that back. I did. I had a couple of months off in between, but I submitted my honours thesis and did my final exams, worked for a couple of weeks, then I had a couple of months off, and then I just worked full time at the same company. So, I think it does go to show the importance of industrial training. If you can do a great job once, during your degree, then that does certainly help. I also think that graduate recruitment 20 years ago wasn't anywhere near as formal and scary as it is now. And I do think I would say that most engineers working in industry don't really, the HR programs take over the recruitment, and many engineers would love to just hire someone by chatting for them and seeing a good fit. But, the process. So I don't have a lot of tips, unfortunately, to you know, on that process, because I was lucky enough not to have to do it. And I don't know if I would have got a job if I'd had to do a graduate recruitment process, because it's a pretty full-on experience, I think.
Cool. And I guess then after that first job, did you keep moving up and moving on into other similar roles in industry, like still consulting and all that?
A little bit. So one of the things that I was really clear with my boss when I was at KBR as my first job was I had two things I wanted to do. One, I wanted to do really cool flood modeling, and two, I wanted to do overseas development work. And there was a really cool project came up in Vietnam that our company had won, and I was like, I want to go to Vietnam, send me to Vietnam. And they couldn't, because it was this horrible catch-22 where you needed experience already to get on those sorts of fun projects. So I was like, right, okay, what am I going to do about this? So I applied for Australian Youth Ambassadors for Development, which is the Australian government's one of the Australian government's volunteer programs. And I spent 8 months in the Philippines working as a hydrologist for the city government of Tagbilaran, which is in the rural province of the Philippines, in Bohol. And it was an amazing experience. And so I took leave without pay from KBR. And
was that like a volunteering?
Yeah, so it was a volunteering position. So in America, it's like Peace Corps. In Australia, we've now got Australian Volunteers International, which runs that program. And yeah, so this was kind of designed for people that wanted to do overseas development work but didn't have any experience. So it was perfect for me. And so I worked as a hydrologist looking at whether the city government could develop a lake for tourism. So they had part of their town, and they thought their town was sort of a gateway for tourists to go to other bits of Bohol, to go diving or to go and see the Chocolate Hills. And so they wanted people to stay in the city. And so they were like, well, if we have this beautiful lake, maybe people would come and spend some more time in the city. And so I was really doing a feasibility study to see if it was. It wasn't very feasible, unfortunately, because the land was owned by lots of people. It was, when I got there, the lake was dry, so it was intermittently dry and wet. But it was an amazing experience for so many reasons. It really helped me understand the politics behind development and the importance of people relationships, and the fact that projects weren't about technical merit necessarily. There were a whole lot of other reasons why projects may or may not get up. And so that was a fascinating process. I also learned to dive. I lived with a community of volunteers. I learned a lot about myself being far away from anything that I was used to. But what I also realized was that I needed, if I really wanted to do this sort of work, I needed far more technical skills. And so when I came back from the Philippines, I had a couple of months secondment to Orica, and I worked on something completely different on polluted groundwater. And then I moved to Queensland and worked for a small consulting company who only did flood modeling, because I really wanted to do that. And so we did heaps of urban development, floodplain kind of work, water sensitive urban design, water quality for mainly new housing developments. And that was everything I wanted from a technical sense. It was really, lots and lots of fun modeling. But after a little while, well, after a few years, and I also spent some time in Melbourne, working for their Melbourne office. So, moved around a little bit, and then decided that actually modeling and data and all those things were things that I really loved. But in consulting, as I said before, you either have lots of deadline pressures or you have lots of budget pressures. And either way, you never get to solve a problem quite to the depth that I was really passionate about. And so I chose to do a PhD, then looking at climate change impacts on water resources systems, mainly because the Al Gore movie had just come out, An Inconvenient Truth.
Yeah.
And I was just like, wow, climate change is such a massive issue that faces us, and we're not doing, there's just so many things that we need to do. So I came back to UNSW to do a PhD. And so, yeah.
Yeah, going to the Philippines for that opportunity really spun off a chain of events that led you back to do a PhD, which is so interesting and made you, I guess, really know what you really wanted to do in your career, which I think is so cool. Yeah.
Yeah, and I mean, I think, you know, in hindsight, it all looks much more organized than it feels at the time. I think, you know, you can easily tell a story of your career that makes it look like everything led to this point, but actually there were so many forking paths there that, you know, when I stopped working for consulting, my other choice was really to go and work for council on the Gold Coast, because they were doing some really interesting work, and I wondered whether that would be somewhere where I wanted to be rather than being on the client side. Who knows what would have happened if I'd picked that as an option instead of a PhD, but I picked the PhD door, so here we are. But I wasn't going to become an academic after I did PhD either, so there you go.
Yeah. So you obviously mentioned PhD. For those, you know, who might be considering that, could you like describe or elaborate on a bit about your experience?
Yeah, so I mean, a PhD is an amazing opportunity. Most, you know, often they're funded, almost always in engineering anyway, they're funded. So you get paid to research something for 3.5 years, working with a few supervisors, and really getting to go into depth of a particular problem, which is, you know, especially after you come from consulting, such a luxury to have time and you know, that freedom to work on what you want to work on and solve problems. And so, yeah, I was looking at, you know, and I think in engineering, we often have quite sort of, even for people that aren't physically in a lab, we sort of have this lab model where there's, you know, kind of projects that your supervisor has. And so you sort of come on board on one of those where, so in my case, my supervisor had some work with the Sydney Catchment Authority where they'd realized that climate models, these massive computer models we use to look at climate change projections, are really bad at reproducing rainfall time series that look like real rainfall time series, and they're particularly bad in getting periods of really wet or really dry over multiple years, right? And so my PhD was really looking at, okay, if we've got these climate models, how do we fix up their simulations so that we can use them for dams or things like that? And so, you know, you're kind of working on, in my case, problems that mattered to industry, but kind of a step or two removed. Like they weren't going to use my findings exactly, but it's helped. And the work that's come out of my PhD has now, over the last 10 years, been used by the Bureau of Meteorology and other water organizations to come up with better estimates of, you know, water projections for the future. So it's pretty cool to see how that research process goes, but it's compared to consulting, it's so different, because consulting projects, we had a couple of months to get an answer and that was it, and then you move on to the next project. Research has far longer timeframes, and so that has good and bad bits. You know, it can feel quite overwhelming at times, just the extent of what we don't know, or the extent of the fact that you don't feel like you're making progress. But when you look back, it's, yeah, it's very satisfying to say, okay, yeah, because of this, we now know that. So
yeah. No, I mean, I myself haven't really, you know, got the industry experience in the consulting, but I know in like during university, there's these things called case competitions, and they kind of give students that experience of working with tight deadlines and trying to consider the budget, and, you know, this, and partially politics as well. But yeah, it seems like you kind of had like a quite a deterministic, you know, experience in navigating yourself to, you know, like Bureau of Meteorology, like you've kind of, yeah. And I was just wondering, like, what was that like in more detail, and for someone who might be considering working in the government or the Bureau, yeah.
Yeah, so after my PhD, I was 100% sure I wasn't going to be an academic. So, you know, you can make the best plans you want, but then you can always change them as well. But what I really wanted to do was get more experience on really large, complex data sets that were real data sets, because my PhD was all about modeled data and evaluating that. I never had missing data. It was all quite organized, and it was, so I was like, I really want to work on messy data, which sounds odd, but it was something I felt like I hadn't really experienced even in consulting. And so towards the end of my PhD, I talked to people about what it might be like to work at the Bureau of Meteorology. At that stage, the Bureau of Meteorology had been recruiting quite heavily for water and hydrologists. They had a new role in managing Australia water data. And so they were becoming one of the biggest employers of hydrologists in Australia. And so that was quite an exciting opportunity to join. And so, yeah, I joined the Bureau of Meteorology. Government, it was a pretty amazing place to work. People, like the Bureau particularly, people are very proud to work there. So that was a, and you'd say, oh, I work at the Bureau. People, I love bomb.gov.au. I look at the radar all the time. And so you feel that pride in the service that they provide for people. And you're just working with so many smart people, meteorologists, climatologists, hydrologists. So it was an amazing place to work. Government is very, fixed in terms of progression and the politics of how positions are filled and stuff is quite a frustrating process. But to be contributing, so I got to work on estimating the 1 in 100 rainfall for all of Australia, the project, and the last time this had been done in Australia was like the mid 1980s. So we were revising these estimates for the whole country. So it was an amazing opportunity to use interesting research skills, but for a very applied project. I also got to do flood forecasting, like over the last couple of weeks we've seen across the East Coast, where the Bureau is issuing flood forecasts for any particular river. When they were particularly busy, then I would come in and help the flood forecasting team. And that was such a contrast to PhD world where, my research may get used 10 years later, whereas this is, you make a flood forecast and people are being evacuated the next hour. So the real time of that was quite exciting and stressful and interesting to be involved with. So I really enjoyed that. But then I realized I kind of missed teaching at UNSW, and so an opportunity came back to be an academic, and I was only on a contract at the Bureau, and so I was looking for what was going to be next, whether that was internally in the Bureau and 10 years later, here I am still at UNSW. So obviously that was a fairly good choice too.
I'm actually curious about that a bit more because, you've been hinting that I wasn't going to come back as an academic. I wasn't going to do this, and then now you're here. I guess you said that it was a contract work at the Bureau of Meteorology, but so even though that was a contract work, you didn't want to go more into government or other weather stuff. You saw the opportunity of academia and teaching and was maybe perhaps, or
yeah, so there was a training course being run on some software that I knew at the Bureau, and I was like, I want to teach that. Why have they got external people to teach that? And I was like, oh, because it's not my job. Oh, maybe I should be teaching, was one of the things that occurred to me. And then for family reasons, I wanted to stay in Sydney. And so that was made, I guess, quite the Bureau's head office is in Melbourne and Canberra, and before COVID, although they were quite good at telecommuting and my team was already spread out, I thought in the long term, I was probably going to have to move to Canberra or Melbourne to work on some of the other projects at the Bureau. So that was another reason that I was, I guess, not 100% sure that the long term would be for me. And as far as other government departments, I think because I love data and doing the modeling and side of things so much, CSIRO would also have been another opportunity for me. They don't have a big water presence in Sydney though, so that was, I guess, another constraint. But more broad government work for me ends up as often a lot of policy or coordination kind of work, and that's not, I guess, where my passion and skills are. So that was, I guess, the university is an amazing place to work because as long as I publish, no one minds what I publish on. So I get huge freedom to work on what I think is interesting. And if it brings in grant money or I can have industry contacts on it, then the structure is such that that's okay for the university. So it's a pretty amazing place to work. And so the opportunity to work with PhD students and then teach as well. And, I think the teaching that I do or have done in terms of informed by my industry experience is really fun as well. So yeah, it's a huge variety working at the university, which is pretty cool.
Yeah. So did you ever come back to the bureau to teach those workshops and all that, or have you just been at the uni teaching all the courses?
So I haven't taught at the bureau, but we have run industry courses on statistics and probability. And I think we do work with the bureau. I've had bureau co-supervisors for honours students, or we get them involved in other stuff, or we have industry funded projects. And so we do keep that connection, which is great. I loved working with the people. And fundamentally, for me, every job, it's the people that you get to work with makes it really fun. So.
Yeah. And so I guess you then got back to being at UNSW and teaching a whole handful of courses. What were some of your highlights and the ones that you were the most keen on teaching?
So I've always loved teaching third year water resources engineering, those of you in civils 3501, because it's such an applied flood hydrology course, and the things that we teach are what happens in industry. And so I think it's a really relevant course. And I think by the time you get to third year, you've learned all the fundamentals, the maths and the general way that the world works. And so we can start getting into the really applied engineering courses, and that's super fun to teach. So, and I love teaching the third year because then you get great honours students coming through and working with you in honours as well. And I love supervising honours projects because, many of our courses are really big, and I don't get to know students one-on-one, especially, when we don't run demonstrations or tutorials, workshops. And so when we get to work with students one-on-one in fourth year with honours projects, it's really fun. And then it was really exciting to help develop the new humanitarian engineering minor and the courses supporting that since about, 20, when did we teach the first one? 2018, I guess.
There wasn't any similar minor or something offered when you were new?
No. So I really designed some of those courses thinking, well, what should I have known before I went to the Philippines? What was I completely underprepared for in terms of, I might know how to calculate a catchment water balance, but I didn't understand that when I was in the Philippines, that meetings would start with prayers, or we would thank God for, the fact that the surveyors were available. And that interplay between culture and geopolitics and my engineering was something that I was underprepared for. And so a lot of the courses I was thinking, well, what should I have known before I went off to do, some work in development? And so, the fundamentals of humanitarian engineering course was sort of thought around some of those principles. And then the humanitarian engineering project course was a great opportunity to, I got to take some students to Nepal for a field trip, which was pretty amazing, to take 8 students there. And we met up with some local Nepalese students, as well as some students from Arizona State University. And so, to be in Nepal with such a great group of students was pretty memorable course to teach as well.
Yeah, no, that sounds great. I think what you're doing, like the initiatives that you've established at the new courses, I think is really good. I think EWB kind of has seen that more recently as well. And, we're trying to promote these types of courses, humanitarian engineering courses as well, as much as we can. Just conscious of time, like we might move on to the final section of the podcast. And so we just have a few audience questions. Obviously, in terms of the recent weeks, Queensland, parts of northern New South Wales, or regions around there have been severely impacted by the flooding and wet weather, and then in some instances even taken some lives, which is quite unfortunate. What's your take on the floods, or like these trends for the upcoming future?
The flooding we've seen has been absolutely devastating. Particularly in the northern rivers, the rainfall totals were outside previous experience. And the response has been mixed, in terms of our ability to deal with that. And I think it's going to ask some hard questions about our emergency response and how people were left, helping themselves. It's not what we want to see, I guess, in general. The loss of life in flooding is always devastating to me. And I think it goes to show that the questions around that I was mentioning before about culture and geopolitics and you know, those sorts of questions, that engineering and science can only get us part of the way to making our world safe and sustainable. And fundamentally, engineers need to work more with people and communities and understand the other barriers that exist that mean that we could have the perfect flood forecast and people may still die because they willingly enter floodwaters. Why is that? What compelled them? Is it overestimating the capability of the car they're in, or is it that they felt like they had no other choice? And in which case, you know, we need to understand that sort of human behavior, because technology won't solve those problems. And so I think increasingly we need engineers that can work so strongly with communities. It's not just a matter of like, here's a flood planning map, make sure you don't build in the floodplain. You know, we need true consultation. And particularly, you know, that needs to understand that different communities have different needs and different availabilities. You know, housing was already quite scarce in the Northern Rivers and expensive, and now it's going to be even worse with so many houses damaged. And so what do we do going forward? You know, like, these events are not going to be less frequent going forward with climate change. We may not see, you know, increases in frequency, but we know that with a warmer atmosphere, the atmosphere will hold more moisture. So when it rains, you know, it's likely that the rain will be more intense, and that when that's coupled with these, you know, patterns that we get of wet and dry, a La Nina event where the catchments are already wet, we know that flood risk will, you know, can be worse, and that it's very uneven. And so we need better ways to explain that risk. I think that you know, that this is a bad summer, and you know, and the flip side of that coin is that those dry years is when, you know, bushfire risk increases. And so we've got very variable climate, and it's going to get more variable, and therefore the extremes will be, you know, worse.
And I know, you know, a point you mentioned was just working with the communities more. Like, in terms of, you know, going forward, how might we deal with these communities that, you know, might be subjected to increased flooding? Is there any mitigation strategies, you know, or like, how do we deal with people who are very attached to where they, you know, kind of reside in?
Yeah, I mean, it's really hard. There's some mitigation options, but Lismore already had a levy. You know, the levy was overtopped because the floods were far higher than anything on record. And you could always build a bigger levy, but there'll always be a bigger flood. And so there's always going to be residual risk. And so it's about understanding what that looks like for any particular location, and then, you know, designing, you know, making sure people keep stuff high or understand where evacuation routes are, or all of these things, so that, I mean, people who've lived in a catchment for a long time have a lot of innate flood knowledge, but people who are new to an area don't. And there's probably, you know, a lot more that we could be doing to make sure that new people are equipped with the information they need to be safe.
And then, you know, just following on, what kind of I guess for, you know, for people who, I guess, aren't directly involved in engineering, you know, say for the average Australian citizen, what might they be able to do in terms of maybe policy changes, or, you know, or other than protesting, actually, what actions can they undertake?
Yeah, so, you know, we all see, you know, turn off the lights or recycle more or stuff like that as climate action. But fundamentally, we need governments that are going to make hard decisions around mitigating carbon and, you know, ensuring that we minimize the impacts as far as we can. And so it's about writing to your local member. It's about electing representatives who truly care about climate, because until there is only so much that individual citizens can do. It needs collective action. And, you know, that's for all levels of government as well, but it's also investing in super funds that are making decisions about where, you know, ethical investment. And it's, not supporting businesses that are, supporting non-climate action. So, your money talks and your vote talks. And that's, to my mind, the biggest difference we can make. You can post on Facebook or you can do whatever, but fundamentally, we live in a capitalist society with a democratic government. And so our two biggest levers are where you spend your money and who you vote in.
Yeah, definitely. That sounds pretty good. I think that might be, that's all the time we have for today, unfortunately. Just to recap today, we definitely went through your whole, I guess, undergrad, or even like your journey from high school to, what you are doing now in terms of research and teaching at UNSW. It's a very insightful journey, and we're very thankful for you being able to share that to us and audiences today. And yeah, I guess to conclude, for audiences, I guess, listening in, if you do have any questions for our guests, feel free to submit in, via our form that we post on all our social media. And, I'd just like to thank Dr. Fiona Johnson one more time for, joining us today and sharing such good advice and insight.
Thanks very much for having me, Rong and Winnie. It's been really fun chatting to you.